Good day, viewers, and welcome to another exciting class with Mr. Simplicity. Today we are looking at the topic determinant of a matrix under matrices. So we want to look at how to find the determinant of a matrix. We are going to start with the examples on the board that says find the determinant of the following matrices. And we are given matrix A, which is a 2 by 2 matrix, and matrix B, which is also a 2 by 2 matrix. So let's see how we handle determinant of a 2 by 2 matrix very quickly. So the determinant of A can be represented with straight lines like this. A equal to 3, 5. This is matrix A now. We are not using a regular bracket. Instead, we are using a straight line. 3, 5, 4, 7. So this is how we represent it. So this will be equal to, okay, in multiplying a 2 by 2 matrix, all you need to do is to cross multiply and take the difference. When you do that, you are going to have, in this case, 3 times 7. Let me write it out. 3 times 7. So what I did, I just multiply these two guys. Okay. Minus, this minus is constant. It's coming from an invisible minus on top of this second column. Okay. So the next will now be 5 times 4. 5 times 4. 5 times 4. So you can see what I did, I cross multiplied and take the difference. Is that okay? So if you check this, this is 21 minus 20. So I'm going to have everything become 21 minus 20, which is 1. So the determinant of this 2 by 2 matrix is 1. Okay? If you want to speed up your working, all you need to do is to say 3 times 7, 21. 5 times 4, 20. You subtract them and you get your answer. This step is not necessary. Okay, except you are the like to show details as you solve it. It's not good for multiple choice. So let's go to the next example, the determinant of matrix B. The determinant of matrix B will be represented as B, which means the brackets will become a straight line. So I have 4 minus 7 and 3, 1. Okay, so this will become 4 times 1, just like we said, cross multiply. 4 times 1 minus 7 times 3. Okay, remember this minus is as a result of an invisible minus in the second row. Is that okay? So when you simplify, 4 times 1 is 4, minus 7 times 3 is minus 21. If you open this bracket, minus minus is plus. So I have 4 plus 21, which is 25. So that's the determinant of the second matrix. So this is how we find the determinant of the 2 by 2 matrix. We are now going to look at other examples that involves 3 by 3 matrix. Mind you, we can only find the determinant of the square matrix. Okay, viewers, welcome to another exciting episode with Mr. Simplicity. Today, we want to look at determinant of a matrix. But in this video, we are looking at 3 by 3 matrix. So on the board, we already have an example that says find the determinant of the following matrices. And the first matrix is matrix P, which is a 3 by 3 matrix, as you can see. And the second matrix is matrix Q, which is a 3 by 3 matrix as well. So I'm taking the two examples so that any case you come across, you will know they are the same as long as it's 3 by 3 matrix. There are actually two ways you can go about this. You can use the Cyrus rule, or you can follow the way I'm going to solve it right now. So let's see. So the first one says we should find determinant of P. Okay, so the determinant of P is equal to, so now we have a straight line, And then we have 3, 2, 1, 1, 4, 1, 3, 5, 7. So this, in a 3 by 3 matrix, we cannot just cross multiply as easily as we did for 2 by 2. So the first thing we can do is to reduce it to multiple 2 by 2 matrix. And in doing that, we can use a row or a column to do the reduction. In order to achieve that, we use all the elements in the first row. 3 is the first element there. Then we open up a 2 by 2 matrix. This is just a method to show. Then the second one, like we said, there is visible sign on top. This one is plus, the second is minus, the third is plus. Those signs are invisible and you use them in splitting the matrix. So the first one is positive 3. Then you open a 2 by 2 matrix. The next is negative 1. Then the 2 by 2 matrix. Then the last one is positive 3. Plus 3. And the 2 by 2 matrix. So having done this, we can now look at the elements that will fill in each of these 2 by 2 matrices. Okay, since this row is already out, to fill the first 2 by 2, you eliminate the first column. If I eliminate the first column, I'm going to have 4, 1, 2, 5, 7. You see it? First will be 4, 1, 5, 7. The same thing, the first row is already out, but we use it to reduce the matrix. So what is remaining now is 2, 1. The middle is going to go out. So fill in the middle, you remove the middle element. So you have 2, 1, 5, 7. And for the last column, you remove the last 2 elements there, and you have 2, 1, 4, 1. So I have succeeded in reducing this 3 by 3 matrix to 3 2 by 2 matrices. Okay? So it's very important you understand what I did just now, because if you do, it makes the work much easier. So from what I explained now, 3 by 3 matrix has to be broken down into a 2 by 2 matrix. And to achieve that, we decide to use the first row and we take note of the invisible signs that are there for each matrix. So the first element is 3. So 3 will take a 2 by 2 matrix by eliminating the numbers under it. The first row is already ignored because that's what you are using to reduce the matrix. So when you take 3, 2 and 1 is gone, it will remain 4, 1, 5, 7. Okay? Then when you take 1, which is a negative, which come with a negative sign, you will eliminate 4 and 1. So we have 2, 1, 5, 7. And when you take 3 as a positive sign invisible, you eliminate 5 and 7. And that is how you know the 4 element that fills it. And that's how you get your reduced form of your matrix. Okay? And if you have done that, the next thing to do is to apply the principle of your 2 by 2 matrix to each of the 2 by 2 matrices here, which is to cross multiply and take the difference. So let's go there. So this becomes 3, which is this 3 here, open bracket, 4 times 7. Remember, we are cross multiplying. 4 times 7, 28, minus, I told you there's a constant minus after the first multiplication. Then 5 times 1, 6.
I
Remember, that
remember.
minus is as a result of the invisible sign here. Okay? So let's take that out. So now we have minus 1 into 2 times 7, 14, minus 5 times 1, 5, plus 3, open brackets. Okay? So we have 2 times 1, 2, minus 4 times 1, 4. Okay? So now if we're going to simplify this, we're going to have 28
Minus 5, 23. 23 times the 3 outside the bracket give us 69. So 69.
Go to the next bracket. 14 minus 5 is 9. 9 times minus 1 is minus 9. Go to the last bracket. 2 minus 4. 2 minus 4 is minus 2. Minus 2 times 3 is minus 6. So if we put everything together, this is 66.
69.
This is minus 9 minus 6. Everything here will give us
54.
Okay, so this is the solution to this determinant of matrix P. Let's look at the solution for matrix Q. It's exactly the same. So determinant of matrix Q will be using a straight line 2, 5, 1 minus 2, 2, 4 minus 3, 1 minus 4. So first, I'm going to use the first row to reduce my column. And don't forget the visible sign. You don't need to write them. This is for you to understand what is happening. Okay, that's why they are visible. They don't need to be seen. So now, the first one is positive 2. Spelling my 2 by 2 matrix. In fact, I can take it immediately because when you take 2, 5 and 1 is gone. So it's remaining this 2, 4, 1 minus 4. Okay. Then the next one is minus 2. Okay. Minus 2. If you know that minus is plus, you don't need to write minus. You can go ahead and write plus 2. Plus 2 and continue. So for reference, so that you understand what happened there, this minus is what we have here. Then the minus 2 in the matrix is what we have in the bracket. So we have a 2 by 2 matrix by removing the element under it. So now it will be 5, 1, 1, 5, 1, 1 minus 4. Okay. So the next one is plus minus 3. Plus minus 3. Also, plus minus is minus. So you could just already write minus 3 and continue solving. So this will be 2 by 2 matrix, which is gotten by removing 1 and minus 4. So I have 5, 1, 2, 4. 5, 1, 2, 4. So my matrix is reduced for 2 by 2 solving. So now, this is 2 will come here, open bracket, cross multiply. 2 times minus 4, that's minus 8, minus 1 times 4, 4. Okay? You go to the next one. Minus is plus, so I have plus 2 into 5 times minus 4 is minus 20, minus 1 times 1 is 1. So I come to the next one. Plus minus is minus, so I have minus 3 into 5 times 4 is 20. Don't forget to write your minus before you go back. 2 times 1 is 2. So now we are ready to simplify. So the first bracket we have minus 8 minus 4, which is minus 12. Minus 12 times 2 is minus 24. Then you go to the next bracket. Minus 20 minus 1 is minus 21. Minus 21 times positive 2 will give me minus 42. Then finally we have 20 minus 2, which is 18. 18 times minus 3 will give us minus 54. So if we put everything together, you are going to have minus 120 as your answer. So this is how you find the determinant of a 3 by 3 matrix. This has brought us to the end of today's lecture. In our next class, we are going to be looking at Cramer's rule or determinant method of solving simultaneous equations. and then you understand one of the application of determinants. Thank you for staying with us today, and today do have a nice day.